class, now I want to talk about the discriminant of a quadratic equation. The discriminant of a quadratic equation is this b squared minus 4ac. You might recognize this as the part that's under the radical in our quadratic formula, okay? So we use this to determine the number of solutions, or zeros, and the type of rational, or complex zeros that we're going to have. So if I was to say end up under the radical with the square root of 36, which is a perfect square, then I would have two rational solutions, because I would have a constant plus a constant divided by a constant, a whole rational constant. If it's positive but it's not a perfect square, like say we had the square root of 20, which factors into 2 square root of 5, right? I'm going to have something irrational. I'm going to have an irrational number left over. If I'm left with the square root of 0, well, the square root of 0 is going to be 0. And if I have negative b plus or minus 0 over 2a, it's just going to be negative b divided by 2a. So I'm left with one rational solution. And if my radical is, say, the square root of negative 9, right? We know that's going to be an imaginary number. So I would have two non-real complex solutions, okay? So if I was to have two rational solutions, let me show you what my graph would look like. So here we have our mini quadratic formula. If I was to have our mini coordinate plane, oh, I'm tongue-tied, guys. Okay, so our mini coordinate plane. If I was to have two rational solutions or two irrational solutions, my graph's going to look like this. And where it crosses the x-axis could be rational or irrational numbers. If I have one rational solution, that means that my vertex of my parabola, which is something we haven't quite talked about yet, but it's where my graph changes directions, where it goes from negative slope to positive slope. If I have one, my vertex is going to be right on the x-axis. And then if I have two non-real complex solutions, my graph is going to look like this. That means I am not crossing the real axis. I have no real zeros, so my graph is going to not cross the x-axis ever. Okay? So it's important to know what our zeros are going to look like. So let's calculate the discriminants of a few quadratic equations, remembering that they have to be in this ax squared plus bx plus c equals 0 form. So I want to find the number and type of solutions. So I have 6x squared minus x minus 15 equals 0. So I'm going to take negative b plus or minus. That's the entire quadratic formula, guys. I don't want the entire quadratic formula. I just want b squared minus 4ac. I want what's under the radical. That's what gives us the discriminant. In this case, a equals 6, b equals negative 1, and c equals negative 15. So I'm going to have negative 1 squared minus 4 times 6 times negative 15. So I'm going to have 1, and then I have negative 4 times 6, which is 24, and I have 24 times 15, but it's two negatives, so it's going to cancel out, equals 360. If I add 1 to that, I get 361. Now, is the square root of 361 a perfect square? No, it's not a perfect square. So I'm going to have, but it is positive. So I'm going to have two irrational solutions. All right, next I have 3x squared minus 4x equals 5. And I want to find, how did I do that? I want to find b squared minus 4ac. But in order to do that, first I have to get it to look like ax squared plus bx plus c equals 0. So I need to go ahead and subtract 5 from both sides to get 3x squared minus 4x plus 5. Okay, minus 5 equals 0. Of course, my pen decides to change color. All right, so now I have a equals 3, b equals negative 4, and c equals negative 5. So I have negative 4 squared minus 4 times 3 times negative 5. That gives me 16. And then I have negative 4 times 3, which is 12, times 5, which is 60. So I have 16 plus 60. That gives me 76. Is 76 a perfect square? No, it is not a perfect square. So I am left with two irrational solutions.